Okay, so today we are going to use area and perimeter notes from yesterday, so you want to have those out. And just a reminder that you need to make sure you've done the quadrilateral property practice and the writing. Okay, so it looks like this from 226. A lot of people still need to turn that in. And also the writing assignment from the last 2 days. If I give it back to you, gotta do that. Okay, so you got your notes out from yesterday. Everything's great. So we're going to talk about the area and perimeter assignment, and we are going to go over some specific types of polygon problems. So look right here. Everyone's looking right here. So 1 through 4 I think should be not too hard. I want everyone to notice there's 2 answers for everything, because the instructions say find the area and the perimeter, like the notes. So if you got the notes, you know what to do, right? You look at number 5. When we talk about a polygon, you cannot find the area unless you have the perimeter, because the formula is 1/2 AP, and that P is the perimeter. So again, make sure you do both. Write the perimeter and use 1/2 AP. Just to skip to it, numbers 15 and on, find the area of each. Now this is saying just find the area, okay? So you don't have to find the perimeter. That's fine. But please remember, some of these triangles are not straight up and down, okay? So for example, this triangle could be redrawn straight up and down like this, okay? Now it might be more obvious what's the base and the height, okay? But just FYI, sometimes it's sideways. You can do it though, all right? You just reposition it. You don't have to redraw it if you get it, that the base is over here instead of on the bottom, and then the height goes through it. All right, and then what else do we got here? Trapezoids. Now this one is area and perimeter, okay? So we did that on the notes. Base 1 plus base 2 times height divided by 2. All right, and then these last 4 are challenging on purpose. I want you to think about it, okay? So again, I don't have like a one-size-fits-all method for these. You got to think about what's given and figure out what's missing. So you try that, all right? But I want everyone to look at number 11, please, okay? So everyone make sure you've opened the packet. You're looking at the back of the front page at number 11. So I want you to draw a line right here, because above that line, okay, numbers 5 through 10 are all regular, normal polygon problems, okay? Because you're given a side and an apothem. So again, remember the animal that comes out in the night and has a crazy face, the apothem, okay? So, however, look at 11, 12, 13, and 14, okay? So on number 11, what do you think the apothem is on number 11? Raise your hand if you think it's 10. If you raised your hand, take that hand and bop yourself on the head. Boop! Because it ain't 10. Here's why. The apothem goes to a midpoint. That 10 does not go to a midpoint, it goes to a vertex. So that's what we call a radius. AKA, that's not the apothem, okay? So on 11, 12, 13, and 14, we don't know the little a apothem. So I'll show you how to do number 11, and I'll show you how to do number 13. That way you can do number 12 and 14, okay? So let me help you out. On number 11, okay? Every single one of these little lines is called a radius, and they're all 10, okay? Now this is what we call an equilateral triangle. So guess what the side length is also going to be? 10, okay? So I have an equilateral triangle of 10, 10, 10. But I need to know what is the apothem. So I'm going to redraw that in a big way after I do something real quick. All right, so let's redraw this triangle in a big way over here, okay? So I got this whole side is 10, 10, and 10. What I'm going to do is I'm going to cut that equilateral triangle down the middle in half, okay? Because this is my apothem that I need to find out. Now I want you to notice, I'm going to do this in blue. That makes for me a right triangle, right? Now, do I know this little length right here? Half of 10, right? So half of 10 is 5. And then I have A, and then I have 10. Okay? Now, last unit, we learned if I have if I have two sides of a right triangle, how do I find the third side? What equation do I use? It starts with the Pythagorean Theorem. Y'all are so smart. And it is a squared plus b squared equals c squared. So let's write that down. So here's A, and here's B, and here's C. Across from 90 is always C, right? So we'll do it right here, okay? So A squared plus 5 squared equals 10 squared. Okay? 5 squared is 25. 10 squared is 100. The two numbers are on different sides, so we're going to subtract. 100 minus 25 is 75. And then we square root. And when we do the square root, we're not going to do a factor tree. We're going to actually get the decimal, because we're writing this down. Yeah? So, square root is 75. 10 million years later after this loads. Y'all know today is Texas Independence Day? Woo! Actually, yeehaw! Woo! Alright. So, that was a good filler. We are going to do the square root of 75. Square root 75. 8.66. So, guess what? This apothem, little a, is 8.66. Now, can I figure out the perimeter? Yep. 10, and there's how many sides? 6 sides. So the perimeter equals 10 times 6, which is 60. And the area is apothem, 8.66, times perimeter, 60, divided by 2. So let's do 8.66 times 60 divided by 2. And I get 259.81. Okay. That's it. Now, do you see how these type of problems take extra steps? You don't know the apothem. You got to figure it out. Then you find the area. I show you this because it'll be on your test. All right. So you got to know how to do this. Now, what about number 13? By the way, when is your test? Next Thursday. Very good. Awesome. So on 13, every side is 8. So down here is a little 8. And guess what? It makes an equilateral triangle of 8, 8, and 8. So once again, I'm going to draw my equilateral triangle of 8, 8, and 8. But I got a missing apothem. What's this little side right here going to be? I'll do it in green. What's this side right here? half of 8? 4. So I got A, 4, and 8. I promise you, this is going to be the exact same process as the one we just did, okay? So let's do Pythagorean Theorem, okay? A squared plus 4 squared equals 8 squared. All right, I'm going to do this a little quickly, so don't blink. 4 squared is 16. 8 squared is 64. These numbers are on different sides. I'm going to have to subtract. A squared equals 48. And now I'm going to use my trusty yellow TI Inspire CX School Property Calculator to do square root of 48. All right, let's do it. 6.93. So my apothem is 6.93. What about my perimeter? So I still have 6 sides here. So I'm going to take 6 times 8. I do 6 times 8, I get 48. So P equals 6 times 8, which is 48. And for area, again, we're going to do little a, so apothem, 6.93, times the perimeter, which we just got is 48, divided by 2. So apothem times perimeter divided by 2. So let's do that. There's the apothem times the perimeter divided by 2. I get 166.28. All right. So with all that said, I did one, number 11. You should be able to do number 12. I did number 13. You should be able to do number 14. Again, I'm showing you the harder ones, but when you do 5, 6, 7, 8, 9, and 10, those are easier ones. You already know the apothem. I'm telling you, but hopefully you see it, okay? So the hardest part about 5 through 10 is you got to find the perimeter, and then you just do A times P divided by 2. That's it. Okay, but again, I gave you some of the harder ones because you might, wink, wink, have one like that on your test next Thursday, right? Right. Good. All right, so let's work on our assignment. Knock it out. Use your formulas from yesterday. If you weren't here, lost your stuff, whatever, there are copies of the notes in the blue bin. So let's knock this out.